Okay, this is what good high quality worm castings look like. I have not sifted these yet. These are straight out of the worm bed, and you can see how nice they are. There are some foreign objects in there, but we'll get rid of those when we sift. So I just wanted you to see what worm castings look like when they're done properly. We have two basic controls. We have a temperature control, which is a bulb type. This is the bulb. I've taken this one apart. It's an old one. And I've disassembled it so we can look at it. This is the cover on it. This particular one is a Johnson Controls A19ABC-24. Then we also have this mechanical time switch. It is very simple. It's an electromechanical device. It has a motor which runs 1 revolution per 24 hours, and you can set on and off with these tabs on it, and we will take a closer look at that in a moment. So this bulb, there are two types. There's one that's filled with gas, there's one that's filled with mercury. I think this particular one is gas filled. When it expands, when the gas expands, it goes, this is the bulb. When the gas expands, it goes into a chamber up here, which it's like a bellows, and it opens and closes. It gets larger and smaller according to the temperature. The higher the temperature, the more the bellows expands. Then you have this control on the front, which you can set to a particular degree. It goes from, looks like -30 to 100 degrees Fahrenheit. And as you turn it, it puts more or less tension on this bellows, and the bellows pushes against this piece of metal. When it goes high enough, it hits this switch, which is called a micro switch. It has 3 terminals on it. Talk about how this system works for the temperature controller. You have a bulb, you have a capillary which goes to a bellows. When the bellows heats, it expands, which pushes the bellows up. When it cools, it moves it down. That goes to a fulcrum, which is a piece of metal mounted on a center point. Then it goes over here to the micro switch. The micro switch has a normally open contact, which does not allow flow when it's in its normal position. It has a normally closed contact, which does allow current to flow in its normal position. Okay, let's say we want to cool. Okay, so we are below the set point and the bellows is contracted, which means the fulcrum is down on this side. Come over here, that means the fulcrum is up on this side, which means that this is in its normal position, which is open, which means the cooling is not on. As the temperature rises, the bellows comes up. That means it goes down on this side, which closes the switch, and it's not in its normal position anymore. It closes this one and opens this one, so that turns on the cooling. As it gets cooler, the bellows goes back down, which means this side of the fulcrum goes down, this side goes up, and it releases the switch, which turns the cooling back off, which is exactly what we would like to do. If it's below, the cooling temperature is below the set point, this is going to be down. Then at that point, you want the heat to be on. So the normally closed will deliver heat. As the heat is applied, the temperature will rise, which will push up on this side of the fulcrum, down on this side of the fulcrum. When it makes the switch, it will open that, turning the heat off, which is what we want to do. As the temperature drops back down, as it goes down, the fulcrum will go down on this side, up on this side, and it will turn the heat back on when it reaches the set point. Okay, so this is fairly simple. Pull this out of the way. The neutral goes here, the hot or line goes here, and whatever your load is goes here, which in our case will be a solenoid. This switch trips from off to on. When it's on, it sends a signal out here. I think we can prove that with this meter. As you can see, right now, it's on. If I flip it here, it turns off. So that would connect power to the solenoid, which would turn the spray nozzle on. This is how the system will work. You've got the hot wire, which has the voltage on it. You have a neutral wire. The hot is black, the neutral is white. And you will ground the case, which is a green wire. This will be the hot. It will go to the AC motor on the timer. When it has reached the proper time, it will close this contact, which will cause this solenoid to open the water line, spraying a mist on the worm bed. When the time is finished, it will open this back up and it will stop the water. Then we have the temperature that we're going to control. So this is the temperature controller. We're going through a normally closed contact. It will go to 2 heat lamps, which are located underneath the worm bed, and they will shine up onto the bottom of the worm bed and heat it. It's fairly simple. When the temperature is reached, this contact will open and it will turn the heat lamps off. When the temperature goes below the desired set point, it will close again and cause these heat lamps to come back on. So it's actually a very simple process. We will actually go and wire this on another video, but this is how it works.